Okay, just a little bit out on its own on electricity. We've got to talk about DC and AC. This is direct current and alternating current. We're going to talk about what the difference is between them. And then the tricky bit, we're going to talk about the frequency of alternating current and how you can find that from a graph. So here's a couple of little circuits to hopefully make us clear about the difference between DC and AC. Here's a battery. This is providing a direct current. So there's a constant push, a constant voltage here. The electrons move round, they're going the same way, all the electrons are moving the same way all the time. Pushing through the resistor here, this is a light bulb, losing their energy here, turning it into light. Okay, so the electrons are just moving one way all the time. Here's an AC supply here, so this is like a mains electricity, this is alternating current. Okay, you'll notice that the electrons here are going forwards and backwards. As they push through the bulb, they still produce light, but the light comes off as pulses or flashes. Obviously, you don't see this in the world. This is because mains AC is a high enough frequency that you can't actually tell that the light is flashing. But the key thing to say is in DC direct current, this comes from batteries. The electrons go the same way all the time. In alternating current, the voltage alternates. That means it changes forwards and backwards. So the electrons move forwards and backwards around the circuit. We can see this in a little bit more detail on these circuits. So here's our direct current. This is like an oscilloscope trace here. So we've got a voltmeter across our bulb. I'm going to turn the switch on. Okay, let the animation go. I've just got a constant voltage. So on this one, the voltage is the same all the time, 9 volts. The electrons, if we could see them on this animation, will be just going round the circuit, constant voltage, straight line trace on the oscilloscope above the 0 line. But if I do the same thing with the AC, let me just pause this a sec, close that switch and restart the trace. If I do the same thing with the AC, okay, what you can see is the trace is going forwards and backwards, okay, because the voltage is going forwards and backwards. Okay, the hard thing to do on this is to work out the frequency. So can you notice on here, this is 2 seconds on my trace. That's 1 complete wave, 2, 3, 4 complete waves. So I've got 4 waves in 2 seconds. That's 2 waves, in 1 second up to there. So 2 waves in 1 second is a frequency of 2 Hertz. If you look up here, you can see that that frequency is set to 2 Hertz. Okay, so we've got to look for how many waves you get in 1 second on the trace. That will tell you the frequency. Okay, the third one is just to give you a little reminder, same sort of circuit, but here I've got a diode. Again, if I just restart the animation so you can see what's going on. Okay, notice here, the supply is AC, so the supply is still doing this, but the diode is only letting the current go through one way, so the voltage across here goes up and down. It goes up and back to 0, but then it doesn't go below 0 because the diode is stopping it. If I turn the diode round, it would just go down and we get this half of the wave. That's just a little reminder of how diodes work, so you can see it's letting the current go forwards, but not backwards.